Hello, everyone. Today we are celebrating, all of us are gathered here today to celebrate Asteroid Day, which is on June 30th. Today I have the great pleasure to introduce Professor Patrick Miller, who many of us know from having done the asteroid search campaign. Professor Patrick Miller is a professor of mathematics at Hardin-Simmons University in Abilene, Texas. He also teaches astronomy. Sorry about that. One sec. Yeah. Professor Patrick Miller teaches introductory astronomy and astronomical research methods at the university. He founded IASC in October 2006. IASC is a citizen science program. It provides high-quality astronomical data to citizen scientists around the world, allowing them the opportunity to make astronomical discoveries of asteroids and to participate in hands-on astronomy. Professor Miller has been working with the Federal Ministry of Science and Technology in Brazil and also the State Ministry of Science and Technology in Rajasthan in India. In Brazil, this has seen IASC give access to tens of thousands of students who are now participating. Professor Miller also serves as the Vice President of the Permanent Council of the Global Hands-on Universe Association. So again, we welcome you, Patrick, and we invite you to talk a little bit more, or please tell us about IASC. We are all very eager to hear about that.
All right, thank you, Mila. Now let me bring up my PowerPoint. So I'm trying to, here we go. All right, so are you able to see that?
Yeah, we can see it.
All right, let me fill this out. As Mila explained, I'm Dr. Patrick Miller. I'm from the Department of Mathematics at Hardin-Simmons University in Texas. And in support of the Asteroid Day celebration in India, I want to talk to you about asteroid threats to Earth and how you too can discover an asteroid. Although from what Mila was saying, it sounds like some of you may have in fact already discovered asteroids. And I'm going to talk more about that. First, let me talk about the asteroids. Here's a graphic that shows you the distribution of what we call the main asteroid belt. The main belt consists of debris, rocky debris. Most of this debris is located between the orbits of Mars, which is marked in red, and Jupiter, which is marked in green. Each green dot that you see there represents a known asteroid at the time that this graphic was made. And the majority of the asteroids reside in that ring or that belt located between those two planets. We refer to that as the main belt. Now, if you look carefully at the graphic, you can see not only are most of the debris or asteroids are located between those two planets outside the Earth's orbit. If you look carefully, you can see some of them are actually located inside the inner solar system, including near the planet Earth, which is marked in blue. And we refer to those as near-Earth objects. The near-Earth objects are the objects that pose an impact risk with Earth and do hit us. We get hit every day by these asteroids, but occasionally get hit by a big one that poses a risk to people, in some cases, the entire planet. Outside the ring, you have other asteroids. These are called the Trojans, and those are asteroids that are in the orbit of the planet Jupiter. The majority of the asteroids, I say, resides in what we call the main belt. that's positioned between 2 to 4 astronomical units. An astronomical unit is the average distance between the Earth and the Sun. So these objects are 2 to 4 times further away from the Sun than is the Earth. And they take anywhere from 6 to 8 years to orbit once around the Sun. So here are some photographs of near-Earth objects, or what we call NEOs. The photograph up there is Phobos. That's actually an asteroid that is in orbit about Mars. It has a diameter of 25 kilometers. Here's Eros. Eros is what we call a Mars-crossing asteroid, or an AMER asteroid. It's 30 kilometers long. And as a matter of fact, I'll show you some photographs here in a moment taken of Eros by the nearest spacecraft launched by NASA in the early 2000s. And here are two others. These are also near Mars. This Gaspra and Ida has a smaller asteroid orbiting around it that we call Dactyl. Now, these objects currently are near Mars, with the exception of Phobos. Phobos won't change its orbit other than getting closer to Mars and one day striking the surface. But Eros and Gaspra and Ida, along with Dactyl, are out near Mars, and over time, their orbits will change. And over time, their orbits will, instead of being near Mars, will be near Earth, in which case they'll pose a risk to our planet, because these asteroids are actually bigger than the asteroids that hit the asteroid that hit in 65 million years ago off the coast of Mexico that destroyed the dinosaurs and about 85% of life. But it won't happen tomorrow. It'll be about 1 million years or so before these objects change from being near Mars to being near the Earth. But this is when I talk about the asteroids. These are the things we're talking about. These are the rocky debris that fill the main belt. Now, I mentioned to you the nearest spacecraft orbiting, going around the asteroid Eros. Here's some photographs from that spacecraft that was in orbit about the asteroid. This asteroid is 2 or 3 times the size of a mountain, 2 or 3 times the size of Mount Everest, for example. Now, looking out into the main belt, Eros isn't in the main belt. Eros is near Mars, but out in the main belt, 2 of the largest is the one in the middle, asteroids in comparison to the moon. So let me talk just a little bit about those 2 asteroids, because NASA has also sent spacecraft to visit both of those asteroids. There, of course, is the moon on the upper right. There's Vesta, and there's the largest asteroid of all, Ceres. NASA sent the Dawn spacecraft out to visit both Vesta and Ceres. The spacecraft went out first to Vesta. It spent a year at Vesta, gathering data. Here's some photographs of that asteroid. And then after a year of observing Vesta, they flew the spacecraft across the asteroid belt, and they went to Ceres. Now, Ceres is the largest of the asteroids. As a matter of fact, it was the first asteroid discovered in the 19th century by Father Giuseppe Piazzi, who was a priest at the Vatican Observatory outside of Rome. And it is the largest of the asteroids. All the asteroids are smaller than this. It's about 900 kilometers across, as I recall. What's interesting, as the Dawn spacecraft approached Ceres, it picked up those 2 white spots on the surface inside that crater. And there was a lot of speculation on what that was. Some people thought it was ice. Some people weren't sure what it was. After the Dawn spacecraft arrived at Ceres and they took some measurements, they realized that what these were salt domes. Underneath that crater is a large reservoir of water. In fact, there's some indication that around the equator of Ceres, there may in fact be an ocean underneath the underneath the surface. What happened was the asteroid that made that crater broke the surface open on Ceres, and water bubbled up from the reservoir underneath. When it reached the surface, it quickly sublimates and changes into vapor, and it left behind any salts that were in the water. So what you're looking at are salt domes, and there's some speculation that those salt domes may still be growing. There still may be water coming up from the surface. What's also interesting is when they got to Ceres and looked around the entire asteroid, they found that other salt domes, and so they concluded from that is that there is a large reservoir of water that goes all the way around underneath the surface of Ceres, parallel to its equator. Well, that's what we're talking about as far as asteroids are concerned. Let me talk to you now about how you too can discover an asteroid by talking about the International Astronomical Search Collaboration. We pronounce, some people call it IASC like Mila, but we pronounce it Isaac. Now I know that IAC doesn't spell Isaac, but this is our program, so we call it anything we want, so we call it Isaac, because that sounds better than IASC. So Isaac was founded, as Mila pointed out, in October 2006 at Hardin-Simmons University. As a matter of fact, it was an undergraduate student and I were sitting around the university one afternoon thinking about things to do. And I mentioned to him that I'd heard about a program that was handled by an organization called Hands-on Universe back in the early 1990s, where they gave photographs or images taken by telescopes. And the students then would search through those photographs, those images, and actually make asteroid discoveries. But that program only lasted maybe 2 or 3 months. But I was interested in doing another program like this, and so that's what we decided to do, my student and I. It is an online educational outreach program. It's targeted in astronomy. It's for high schools, colleges, amateur astronomy groups. We often have younger groups, middle schools, even or elementary schools that participate. And we use images from a professional observatory up to 2 professional observatories, and we send these out to the groups each month. And they're able to make the students and amateurs who are participating each month are able to make original discoveries of asteroids. These discoveries, once they're made, then we officially report them on behalf of the students to the Minor Planet Center at Harvard. The Minor Planet Center at Harvard is the world's official body. It's recognized by the International Astronomical Union. It's responsible for maintaining all the information about the asteroids and other small bodies that reside in the solar system, such as comets and objects from in the Kuiper Belt, another reservoir or region of debris located out past the orbit of Neptune. When we started, there we go. We had 5 schools participating. They were all 5 schools from the United States. It was our first campaign in October 2006. We made some changes in the program over the holidays, holidays of November, December, after this first campaign was over with. And when we came back in the spring of 2007, we were able to expand the program to 40. Some of which were schools in Poland and schools in Morocco, other than the United States. Since then, it's grown every single year. The program has grown to over 10,000 groups, citizen science groups. These would be high schools and astronomy groups. 10,000. That's about 70,000 students, represents about 70,000 students per year. And they come in from 98 countries. So we grew from 5 starting in October 2006. So today, we're now over 10,000 participating groups. in not just one country, but we're in 98 countries. Participants in the program have discovered more than 2,500 main belt asteroids that have provisional designations. That means they've been confirmed and observed a second time. They've been confirmed. And we've had 2 Earth-threatening NEOs, more than 10 of the Jupiter asteroids, Trojan asteroids. And we've also had one of our students discover a comet, a Jupiter family comet. Since February of 1st, 2019, we made some changes in our program. There have been a total of 17,000 faint main belt asteroids that have been detected and reported to the Minor Planet Center on behalf of the participating students, 17,000. And what's important about these faint asteroids is that they've not been reported by any of the large NASA sky surveys. These are original detections, original discoveries made by the participating students. As a matter of fact, last month we had a group in Brazil who discovered an Amor asteroid, an asteroid crossing Mars's orbit, and they were the first person to report. They were the first group to report it, and they're now recognized by the Minor Planet Center as the discoverers of this near Earth object. By the way, 1% of these 17,000 are NEO candidates, the ones that potentially threaten the Earth, like the one I was telling you about, the Amor asteroid discovered by the Brazilian school group last month. 106 of these main belt asteroids have been cataloged and numbered by the International Astronomical Union in Paris. Once it's a lengthy procedure for them to become numbered, but once they are numbered, and that takes about 6 or 8 years typically for that to happen, then they become cataloged, and the people who made the discovery then are allowed to propose a name for consideration to the International Astronomical Union. And so that's what's happening now. Those 106, most of them have already been named, but those 106 are now being named by their citizen science or student discoverers. Now here's how the program works. It's pretty basic. This is one of the telescopes we work with. This is the 1.8 meter Pan-STARRS telescope at the University of Hawaii, located on Haleakala, island of Maui. I'll tell you more about that telescope here in a minute. We get each night of a monthly campaign, a 30-day campaign, we get packets of 4 images from them taken over a 30-minute time period at the same area of the sky. We then bundle those up and put those out onto our website and give those to the participating groups for that month. They, in turn, download image sets and then use the program Astrometrica to search for, discover, and measure asteroids. Now, each school gets about, or each participating group gets 25 of these packets, and we don't duplicate. We don't do duplicates. So every participating group gets their own set. So you're not sharing your sets with other schools or other groups. As a team participating in ISAC, you're getting your own 25 sets. And then you've got 30 days to complete the analysis of those 25 sets. And you do that through using Astrometrica. Now, if you happen to make a discovery, the Minor Planet Center requires that the discovery be confirmed, that is, observed a second time, usually within 7 to 10 days. It can be longer. Sometimes it is longer. But we do have, in some cases, where we'll go out and report the first detection to other observatories, like Las Cruces Observatory, using the 2-meter Faulkes telescope. We've used that in the past, and we repeat the process. And then we do the confirmation and take that confirmation and combine it with the students' original observations and detections, and present those to the Minor Planet Center. at Harvard. So that's how it works. When the students run Astrometrica on a program or using images, it's set up to blink back and forth. Now I'm only showing you two here. Astrometrica uses, well, we use four images that are blinking back and forth, but we align the images. These two images are aligned. You can see that because the stars are not moving. And then as you blink back and forth over time, anything that's moving will shift position. So if you look up there at the top center, you can see an asteroid moving back and forth, blinking back and forth. And if you look down here at the bottom center, you can see another asteroid moving back and forth. These images were the test images that we got from Pan-STARRS in 2010 to see if we could do this. And we made, in the very first time we even looked at the Pan-STARRS images, we discovered two asteroids, as shown in this, as you blink back and forth on this one. I mentioned the telescope, Pan-STARRS. Pan-STARRS stands for Panoramic Survey Telescope and Rapid Response System. There's a photograph of the Pan-STARRS 1 telescope. There are actually two telescopes there. And they're side by side. There's a Pan-STARRS 1 observatory, and right next to it is a Pan-STARRS 2 observatory. We get images from both observatory, and distribute those out to the participating groups. It's the telescope, the observatory, is managed by the Institute for Astronomy at the University of Hawaii. Of course, it's not the world's largest telescope, but it currently has, or maybe it's now the second. I say it's the world's largest telescope. Since then, they've built a largest digital camera. They've since then built another camera, I think is even bigger, that goes with the Rubin Observatory, LSST in Chile. But it's an enormous camera. It produces images that stretch 7 square degrees across the sky. That's 6 times the size of full moon. From an astronomer's point of view, that's huge. And during a month, they can actually scan the entire sky, take images of the entire sky twice over an entire month. One image contains 1.4 billion pixels, not mega, but billion pixels. They're huge images. So during a monthly campaign, our monthly campaigns run each month. We start in when the moon is at third quarter and ends when the moon returns to third quarter. During that campaign, we'll get anywhere from 65 to 75 of these massive images from Pan-STARRS, and then we take those big images and we cut them into smaller groups, smaller fields, about 200, 208, and then we distribute those out to anywhere from 300 to 500 teams each month. And from one image, just one image, the students participating can observe more than 150 main belt asteroids. Another telescope we use is the Catalina Sky Survey on Mount Lemmon. That one is in Arizona. It's managed by the Lunar and Planetary Laboratory at the University of Arizona. And down there's a photograph of the G96 observatory, where we also get images from them. Catalina Sky Survey and Pan-STARRS are the largest sky surveys in the world, and they participate actively, or IASC works directly with them to provide images out to the schools. Here's some information about the cameras. It's not as big as the one at Pan-STARRS, but we do make discoveries with that. Now, here are some of the students in the past who have made discoveries. This is a young schoolgirl in Massachusetts, and I remember the night that I found out that she had made a discovery. So I sent her an email, and it turned out that she was still up, and And she was downstairs in her parents' rec room and watching TV or looking at asteroids, I don't know what. And when she found that, she got all excited and started singing and dancing. And she went up and started singing and dancing around her parents who were in the room watching television. And they looked at her and they thought she was crazy. And she said, "Well, I discovered an asteroid." They said, "Well, you are crazy." But she did discover an asteroid. Later on, she went, got some recognition by a local astronomy club and gave some talks at a nearby university, and has since gone to college and studied science and math. These are students close to me there in Texas. They're at they're at a community college, a 2-year school in the Dallas area of Texas. Here's some students in Brazil. These are students at a federal observatory near, they were in southern Brazil, Puerto Alegre. And they also made a number of discoveries. Bulgaria. Each year we have about 45 schools and groups that participate from Bulgaria. And that's managed by their national observatory in Rohan. This is China. That lady there is Hongfeng Gao, who's at the time was with the National Observatory China. And she's there with students from Beijing High School, pointing at a star in astrometrica. But she has about 20 groups each year in the Beijing area that participate. We've got other groups that participate from China, from other parts of the country. This is Portugal. We have in the Portuguese-speaking countries, Portugal and the Portuguese-speaking countries, other than Brazil, we have about 75 schools that participate. A lot of middle schools participate. This is Japan, Shizuoka University in Japan. Here's another picture of students in Japan. These are students in the United States. These are high school students near Washington. Another group near Washington, Arlington, at a high school. These are some students in Mozambique who are looking for asteroids. India. In India, we have around 2,000 groups that participate each year from India. Poland was one of the first countries to participate in IASC. And this was a ceremony they were having after a campaign where the awards were being presented to the students who participated in the group. These were high school students. I mentioned to you Brazil. Brazil actually has more schools participating than even India. India has 2,000 a year. Brazil has 3,000 a year. We work closely with the federal government in Brazil, the Ministry of Science, Technology, and Innovation, the MCTI, to coordinate these 3,000 schools a year. And next year we want to be 5 schools. They recruit, train, and then we provide the space for them in IASC campaigns. But these students are near Rio de Janeiro in Brazil. Sao Tome and Principe, that's a Portuguese-speaking country off the coast of Africa. And this is Morocco. In fact, I'm currently in Morocco, where I'm teaching a class at a university in Ifrane. This is a group from Morocco that participated a number of years ago. Notice they're holding certificates. The one's upside down, I just noticed. We send out certificates to all the schools, all the students who participate and make an observation. They receive a certificate. So in closing here, the IASC is funded through NASA. It has been since 2018. We've had 3 grants. Grant number, the one there in the middle, actually completes on asteroid J, June 30th. And the grant number 3 starts the next day on July the 1st. But our grants are through the Planetary Defense Coordination Office. And the purpose of the course, the Planetary Defense Coordination Office, located at NASA headquarters, is to search for any Earth-threatening asteroids. And IASC participates in that, and it's possible, like the students did last month in Brazil, that if you participate in IASC, you may discover an Earth-threatening asteroid, or discover one of the many other asteroids that reside in the asteroid belt. All right, so that's information about Isaac. Now, if you got some questions, I'll be happy to.
Thank you, Patrick. That was great for all of us. So many of us here participate in IASC or ISAC. So it's great for all of us to find out more about the telescope that you use and how the program flow works. So with that, I'll take some questions. Anybody has any questions? You can unmute yourself. So Mangala Shailesh asks, how can we join?
Well, that's easy. Go to the internet and look up Isaac. We have a website. It's and on that website we have where you can click to join. So if you click that and fill in the information, then my staff will contact you in a couple of days, and they'll arrange for you to participate. Sometimes if you're just an individual wanting to participate, sometimes we try to link you up with other individuals. But if not, sometimes we just allow individuals themselves to participate. We like you to participate in teams. Typically, a team has 3 to 5 partners. But just go to the website and contact us, and we'll take care of it immediately.
And Mangala, and for some of you here, there's STEM and Space, and there's also SA Citizen Science, who are some of the coordinators of this talk today. We also run campaigns where you can join with us to participate if you'd like to. Sandeep Rana, do you have a question?
Ma'am, when was found IASC?
Can you repeat your question?
Ma'am, when was found IASC?
When was it formed?
IASC.
Yeah. Okay. What is your question? What does IASC stand for, or when was it formed?
Ma'am, when was it found?
Okay. Patrick, you mentioned it, but maybe you can.
Okay, she's asking when it was founded. Yeah, it was founded in October 2006. A student and I were sitting in my office one afternoon talking about something trying to do something in astronomy education. And I mentioned that this had been tried before, asteroid detection had been tried before, but had only lasted a couple of months. We've set something up that lasts, we hope, forever. But it was 2006 when we first started, that fall.
Thank you for that. And Shubhendu Paul, would you like to ask a question?
Yes, sir. I am Shobji Pal. And it was indeed a great presentation by you. And the question which arises in my mind is that as we are detecting the asteroids and some of the near Earth object candidates are also coming out, so is there any threat that our Earth will be getting in the next 100 years? The question is.
Well, no Earth, no extinction level threat. But about every 100 years or so, we get hit by an asteroid big enough to take out a city. And there are more of those out there than the ones that would take out our planet. The last time we got hit by one that did damage to our planet was 65 million years ago. We know for a fact that there aren't any of those out there within the next million years or so that will threaten us. I mentioned to you the asteroids out near Mars. They will eventually threaten the Earth, but it'll be a million years before they. Right now, they're threatening Mars. It'll be a million years before they threaten the Earth. But the ones that threaten cities are much more likely and actually a much bigger risk. There was an event that took place, I think in 2012, was it? Over a city in Russia called Chelyabinsk. And that one was an airburst. The asteroid exploded in the air about 60 kilometers away from the city. But that explosion, even 60 kilometers away from the city, did damage the city. It knocked down construction walls. It broke windows, and flying glass injured about 1,500 people, and they had to go to the hospital for treatment. Had that event occurred closer to Chelyabinsk, people would have died. Now, we know in the past people have died. There was an event that took place in the United States, in Arizona, about 50,000 years ago, and Native American Indians were present at that time. And an asteroid hit that knocked a hole in the ground about 2 kilometers across. And we know that some Indians who were living there were killed at the time, because today that's considered to be a religious site by the Native American Indians, and they come to that site once a year in homage to their ancestors who were killed. But currently, it's the city killers that I would be worried about.
Okay, so thank you, sir. It was a great experience to hear from you.
You're welcome.
Sakina Ora, would you like to ask your question?
So, how many asteroids have you found until now? Has IASC found until now?
Well, that's a kind of a tough question to answer. We found at least 17,000 or so, but there's a process that you have to go through before they're actually considered to be a discovery. They have to be observed a second time. That is, they have to be confirmed. To date, we've had over almost 3,000 of those that have been confirmed. Before they're actually considered to be a discovery, then they have to be observed a number of times until the orbit's fully determined. Once that's happened, then the International Astronomical Union catalogs them and gives them a number. And we have, I think, around 100, 106, 108 so far, and that number continues to grow every year that have been cataloged and numbered. Now, the nice thing about the ones that are cataloged and numbered is that if you're the one that made the discovery, then you can name the asteroid.
Thank you, sir.
Arijit, would you like to ask your question?
Yes. So I'm Ariji, and I'm really glad to be present here and to hear you. So my question is, as a student, how can we emphasize or indulge more in the studies, in this kind of studies, like to research in future?
I'm not sure understood that. What was his question, Mila?
I think he's asking how can we include more such programs into our
Yes, sir. I
curriculum?
was asking,
Oh.
how can we include more such programs in the future studies, like to indulge more into this conversational topics?
So, Arijit, are you asking how you can go into this kind of a thing as more into projects or careers in this?
Yes, yes.
Okay,
And
so
as a student, how to indulge more into it?
right.
Well,
How can they prepare themselves more for going into such kind of research later on?
Well, other than to go to the university and study
Right.
astronomy would be the best thing to do. But let me tell you about this. Isaac is part of the NASA Citizen Science Projects. We're an official project by NASA, and there are about 20 or 30 of these programs. Some are in astronomy, some are in other areas of science like geology, meteorology, oceanography, even icebergs. They have a program there. And if you're interested in doing other hands-on science from home, you can, in addition to Isaac, you can go to these other programs. They're online. I would just check NASA. Just do a Google search on NASA Citizen Science, and you'll find that there are many other opportunities for you to do hands-on and do original science, even as a student.
Okay, sir. Thank you.
And I think, the organizers of this meeting here today, SA Citizen Science Group, they do introduce several citizen science projects occasionally. So that would be a good way to join and be involved. So Tanuja, do you have a question?
Good morning, sir. Good afternoon, sir, from your side, because as you are living in Morocco. So I would like to ask you some questions about this IASC, as I am a teenager studying in 9th standard. So, sir, can teenagers from India join IASC, and is there any branch of IASC in India?
Well, okay, I didn't quite understand the last question you asked. Yes, you can join, Isaac. The best way to do that, as I mentioned earlier, is to go to, well, you can talk to Mila. Dr. Mitra, she has a program where she organizes groups to participate in Isaac every year. You can also come in and if you go to the Isaac website, just do a Google search on it, you'll find it. There's a place where you can, when you get to the page, or main page, is you can click on an icon there and join. It says join, and you can fill the information out, and we'll contact you and get you actively involved. Now, I'm not sure what the last question was.
He's saying, are there any branches? So there's no branch, but there are some coordinators in India, including STEM and Space, that gather students, and we participate, a few times a year. There are others today in this meeting. Amritanshu, Hex-star Universe, we all run some campaigns. So you can connect to any of us and we can include you in our campaign. Otherwise, like Patrick says, iasc.cosmosearch.org. No, Cosmos Search. You can just look for IASC Cosmos Search and there will be a register. So you can go through that, or you can contact one of us here.
Yeah, we have, it's interesting. We have, I don't know, probably 10 or so different groups throughout India that organize local groups.
Thank
So
you.
are there any other questions I haven't taken? I'm not sure. Yeah, do you have another question, Tanuja?
Yes, sir. I have another question that as I want to make my career in astrophysics and astronomy, so what should I do for my studies after 12th?
Well, you need to go to university. The best thing you can do for yourself, if you go to a university that doesn't have an astronomy program or astrophysics program, is to get degrees in math and physics. With a strong background in math and physics, I would get 2 degrees. Then you can go to graduate school and then branch off into astronomy, astrophysics, or any field of physics that may interest you at that time.
So, sir, for that, do I have to start my studies from now on only?
So, yeah, so that depends on the country, of course, but yeah, you do have to start choosing science streams and, with the math and computer science focus also, so that you can be on the right track.
Okay,
Okay,
sir.
so maybe we'll take one more question, which is Mangala asks, how can we stop an asteroid that comes near the Earth that is a threat?
Well, what I tell my friends about that, I said, if ever I go to your house someday and knock on your door and say to you, run, don't ask me any questions, just run. Because there's probably nothing you can do if it's that close. However, getting back to the Planetary Defense Coordination Office in NASA, the one that funds ISAC, they have a program, and they do drills twice a year where they simulate what happens when a city killer asteroid lands near or inside a major metropolitan area, and then what they would do to protect the people, because in many cases you won't even see it coming; it just hits. The stuff that we can see coming towards us, there is something we can do, and the further away or the sooner that we know it's going to hit us, the better. The easier it is to do something about it. If it's far enough away, all you have to do is just nudge it a bit. You don't have to make a major change in its orbit. There's several schemes to do that. One is to detonate a nuclear weapon, a bomb against the side of it, and that would certainly move it a bit. There have been some other people who suggest you paint them white and black and let the sun do the work. Others suggest you attach solar sails to it, but probably the bomb would be the best way to actually make the change. When it gets closer to you, it takes much more energy to deflect the asteroid, and there you'd have to do something more drastic. I'm not sure what you would do if it gets too close to you. Probably nothing you can do.
But missions like DART have started, right? They
directly
deflected an asteroid, so maybe things like that will be researched more.
Yeah, they went out and changed the orbit of an asteroid orbiting an asteroid orbiting an asteroid.
Right, it's a binary asteroid. Yeah.
Right.
Okay, so I think we'll take the last question, Deepika, because Patrick sir has to go on to another meeting. So Deepika.
Hello, ma'am. Hello, sir. My question also is related to career. I also want to become astrophysicist. Now I'm in master's in physics. If I want to do like a doctorate in US or get into NASA, what should I do?
Well, you just need to contact universities directly. Now, as far as NASA is concerned, I'm not sure how the universities are related to NASA. They probably have some joint programs. You'd have to contact NASA about that. I don't know what those are. But as far as graduate work in astrophysics or astronomy, there's all sorts of opportunity here in the United States at many of the major institutions, even some of the smaller institutions, for to do that. For example, in Texas, there's the University of Texas at Austin. They maintain the McDonald Observatory, which is has the third largest telescope in the world. There's Texas A&M in Bryan, Texas, and they are also very, very, very famous in astrophysics. And they have an observatory at the South Pole, or in Antarctica, and elsewhere throughout the state. And Texas is typical. New York and California, any of those states will have major universities where you can apply and possibly get support for a PhD, a doctorate.
Thank you so much, sir.
So with that, I think we'll all thank Patrick for joining us today and telling us so much about the program, and encouraging all the students how to join this program, as well as how to join astronomy as a career. So thank you again for joining us.
Oh, thank you for inviting me.
Hex-star or Shomajit, would you like to close this?
Right. Bye.
Bye. Bye, everyone.
Thank you.
Thanks for joining, and happy Asteroid Day.
Bye.
Thank you, sir.